Now we're going to put it all together and we're going to talk about the entire real number system. And if you're going to teach K through 8, this is absolutely one of the things that you have got to have a handle on, and that is how the number sets are all lined up and who's a subset of who and all of that. So real number system, super important. Start off with the real numbers. Every number in the real number set is either rational or it's not rational. That's the first distinction, is you either have rational numbers or you have numbers that are not rational, irrational. And then going down from there, from the rational numbers, you have the integers, then you have the whole numbers, and you have the natural numbers. Now, the way kids learn these numbers and the way that the numbers have been taught in this course is we start at the bottom, start at the beginning, and then we work our way up. So let's do a quick review of all the numbers in these number sets. So the natural numbers, or the counting numbers, those only consist of positive numbers. That's like 1, 2, 3, 4, etc. Like when kids first learn to count, they learn to start with the number 1. So those are your natural numbers. The whole numbers just add in 0 and then all of your positive numbers. So it introduces the concept of 0. The next concept you learn is the integers. That's your positive and negative numbers. So like, this is when we learn about that there are these things called negative numbers in the world. So see how we're just sort of building on each one? So the natural numbers are included in the whole numbers, and the whole numbers are included in the integers, and the integers are included in the rational numbers. So see, these are all subsets. And all of these lower sets belong to the sets above them. So the rational numbers, those are the ones that you can either write as a fraction or you can write them as a decimal. And if you write them as a decimal, it will either terminate, meaning it stops, or it will repeat. So the rational numbers are all your fractions and your decimals that either terminate or repeat. The irrational numbers are the ones like pi and square root of 2, where you don't have you don't have perfect squares, right? So square root of 2, square root of 5, all these weird ones that would give you these crazy decimal numbers, those are the irrational numbers. And all of them come together to make the real numbers. So if you're in a set, you're also in the sets that are above it, right? So all the natural numbers are part of the whole numbers, which are part of the integers, which are part of the rational numbers, which are part of the real numbers. So I would suggest you being able to maybe draw this. It's kind of like this umbrella. Maybe you want to come up with a sentence. I don't have a cute example of a sentence that you could use to remember the order. But real, rational, integer, whole, natural. That's the order they go in, and you definitely need to know that. So what we're going to do for the rest of this video is we're just going to fill out a chart, and we're going to decide what number sets these numbers belong to. And I've got them in order: natural, whole, integer, rational, irrational. It's a given that these are all real numbers, so I'm not going to mark off that they're all real. So let's start with 1/2. Is 1/2 a natural number? Well, no, 1/2 is a fraction, and fractions don't start until we get to rational numbers. So the first number set this fraction belongs to is the rationals. It's not natural, it's not whole, it's not an integer, it's just rational, but it is not irrational. Right? You can only have a check in one of these two boxes at the end. So that one, the fraction, is just rational. So again, I knew that because when I looked at it, it was a fraction. How about -4? So where do the negative numbers start? Negative numbers don't start till we get to the integers. So -4 is an integer, and it's also rational. It's underneath the rational numbers. You could write it as -4/1, and it would look like a fraction. So it's rational. But the fact that it was negative told me to start at the integers. How about 6? Little kids, when they learn to count, 6 is one of the numbers they come to. So 6 is actually a natural number, and it's a whole number, and it's an integer, and if you write it 6/1, it's a rational number. How about this one? 0.56 repeating. Okay, so that's a repeating decimal. Repeating decimals are here. They start with rational. So a repeating decimal is a rational number. It's rational, it's got a pattern to it. Square root of 8, which 8 is 2 times 2 times 2. There's a pair. So you could write this as 2 square root of 2, but do you see how you still got this weird square root part that's left there that won't go away? That's one of those weird irrational numbers because it's not a perfect square. So that one is just irrational. It doesn't fall into any of these others. Sometimes they'll try to trick you and they'll give you a square root, making you think it's irrational. But the square root of 81, that's actually a perfect square. That's 9. And 9 is a nice whole number. In fact, it's a positive whole number, so it's a natural number. So actually, this one is natural and whole and an integer and also rational. They were just trying to be sneaky by giving you square root notation. But if it turns into a whole number, it's actually a natural number, then you can mark all those off, right? It belongs to all those sets. And then the last one is 5.5. If you wanted to write that as a decimal, it would be 5.5, or you could write it as an improper fraction. It would be, 11 halves. Either way, it's a decimal that stops. It's a fraction. Decimals that stop and fractions, those don't start till you get to the rationals. So this one is just a rational number. So this is absolutely something that you need to be able to do, is if I give you a number, you have to be able to tell me what number sets they belong to. So make sure when you're studying that you know how to recreate this picture.